Good day everyone. On behalf of Group 2, I'd like to welcome you today. I'm going to talk about our Laboratory 3 experiment. By the end of this presentation, you'll know how we came up with the solution to a problem. So, what is the problem? The definition of a problem is something that has to be solved or unpleasant or undesirable that needs to be corrected. Our problem in this scenario is how can we inactivate the presence of the potential biological weapon that produces a 3-part toxin which is lethal to spores on skin and lungs. But, as we all know, in any problem there is always a solution. So, we came up with a possible solution. What should we do? We will make a protective device that ensures the biological weapon container will not break when dropped, so that the biological weapon can move to another place via airdrop for inactivation. For us to make this possible, we assigned different engineers in specific fields to manage the roles. We have the following: Brent as aerospace engineer, Carlos and Wendell as the theoretical engineer, Kyle as the materials engineer, Brent as the construction engineer, Brent as the mechanical engineer, Andre as civil engineer, and Simon as disaster and risk engineer. The specific tasks that the assigned roles has to do are: the aerospace engineer has to lead the team in the launching of the device. The theoretical engineer has to explain the science concepts where the device is based upon. The materials engineer is to explain the properties of materials used in the device or improvements made to attain desired performance. The construction engineer is to lead the team in the assembly of the device. The mechanical engineer is to check the structural integrity of the device as planned and its financial implications. Civil engineer is to illustrate the design with specifications. And the disaster and risk engineer is to be responsible for the waste management. Materials. What are the materials needed? 1.5 Manila paper, which will serve as the top vent and the protection of the egg. Scissors for cutting. 1 meter masking tape, which will stick the materials to each other. 1 meter yarn, which will serve as a support of the protective device body and the parachute as it carries the egg. And 1 egg, which will act as the biological weapon. Biological weapon container. This is the device that ensures the safety of the airdrop. But why parachute? Since our problem is to prevent the biological weapon from breaking down when airdropping, a parachute slows the vertical descent of a body falling through the atmosphere or the velocity of a body moving horizontally. The parachute increases the body's surface area, and this increased air resistance slows the body in motion. Purpose. Why did we use this design? We use this design to ensure that the body structure of the egg is more indestructible and durable to protect the egg inside it. The theories that were applied in this experiment are Newton's first law of motion. We can apply this as the egg is falling. It will continue to move down at a constant speed until acted upon by a net force, which is the parachute. Once the parachute is activated, the egg is slowed down because the net force has changed. The next is Newton's second law of motion. We can apply this to the flying off of an egg when the parachute hasn't operated yet. The egg accelerates downward because of the gravity at a speed depending on its mass and how strong gravity is. The last theory is Newton's third law of motion. I can apply this to the deployment of the parachute. The action is the operation of the parachute, while the reaction is the decrease in velocity. The video below is about the construction of our prototype device. In this video, we can see how we test the prototype at varying heights. The results in the testing of the prototype device. On the 1 meter height, the egg didn't break. On the 2 meters height, the egg didn't break. And on the second floor of the house, the egg also didn't break. Disaster and risk. Waste management. The egg was stored and can still be consumed, while the other materials can still be reused and the other materials can be recycled.
Conclusion. We are able to inactivate the presence of the potential biological weapon. The egg did not break in any varied heights. That means we are able to make the best protective device that ensures the biological weapon container will not break when dropped, so that the biological weapon can move to another place via airdrop for inactivation. We are proud of our engineers because they did their best in making this project successful.